Okay, so this is our part number 2 for lecture 4. In this video, we are going to learn vector data model. Before we get started, I want to remind you what GIS is and the nature of geographic information. As we learned in lecture number 1, GIS is a set of computing techniques for capturing, representing, managing, analyzing, and visualizing geographic information. And when we talk about data model, we're really talking about data representation. Remember, there are 4 aspects of geographic information and data: location, spatial topology, thematic attributes, and time. For any type of geographic information, we must have location and thematic attributes. Spatial topology and time, they're optional, right? So in this video, in this lecture, we are going to talk about the data model. But for any data model, we need to find a way to represent those 4 aspects, or at least location and thematic attributes. So keep that in mind, how each data model represent those 4 aspects, right? Okay, so let's take a look at how vector data model address this question. Okay. All right. So vector data model. How location is stored in vector data model? As we know, as we have learned from the last part of this lecture, well, when you use vector data model, we are talking about the geometric elements, points, line, or polyline, and polygons, right? So how to represent location of a point? Well, set up a coordinate system, right? X and Y, as you can see here. Then how to record the location of this specific point, in this case at the house? Well, X and Y, right? Coordinates of the point. How about a line like this river? Well, river, we need to use a sequence of points defining the shape of the line, right? So you can see here, those points, they help us define the shape of this river. Oh, this river have a turn over here, have another turn over here, right? So we call those points shape points. And when we try to record the location or represent the location of this river, we just need to record the coordinates of those shape points. But you need to do that in order, right? Because you cannot, go randomly from this point to another point. We need to follow a certain order. Then how about polygon? Same thing. We need to define the shape points first. Okay, define those points. Help us define the shape of this polygon, and then we need to record the coordinates of those shape points in that order. But you also need to go back to the starting point, right? Because any polygon need to be closed, right? So this basically is a simple way for vector data model to record the location. As you can see here, especially for point, right? The location can be very exact, okay? One thing keep in mind, okay, here, if we just record location in this way, okay, there's no spatial relationship recorded in this specific vector data model, right? So this type of vector data model, we call that entity by entity vector data model. No topology, or, okay, it's kind of messy. Okay, so we call that spaghetti vector data model. Okay, just FYI, no spatial topology here. Then how about thematic attributes is recorded in vector data model? Again, very simple in tables, as you have known, as you have learned from your lab practice. Okay, so if you right-click on certain layer, for example, United States, the contiguous United States. Okay, well, right-click on that, go to properties. Oh, I'm sorry, open attribute table. Okay, you will see a table. Okay, so this table each column, as you can see here, each column, we call that in GIS, we call that a field. So representing one thematic attribute of the spatial features. For example, you can represent the state name. You can represent, the FIPS code, okay, or population in 2000, right? Each column is a specific thematic attribute of spatial features, in this case, state. And the row is called a record. Okay, each row is called record. Each record basically is a spatial object or spatial feature. In this case, is a state. Okay, so we just use this simple table to represent thematic attributes. This table have a fancy name. We call that relational database. Okay, so why call that relational database? Sounds quite complicated. Well, because a table is a relation of columns and rows, right? So to summarize, we are in GIS, we organize thematic data in one or more relations with unique key identifying each row. So each row we call that a record. Each column we call that a field. Okay, or attribute. Okay, but here, keep in mind, one thing you need to keep in mind is you can add the field, right? For example, for each state, for each polygon, you want to add another thing. For example, in this case, it's a temperature. Okay, it's a temperature, and to record, for example, the annual temperature of that state. Well, you actually can go here, okay, to add a field. But when you add a field, you will be asked to specify the data type of that field. Okay, so for example, here, I can use an integer. I can use so-called long integer or float or double or text or date, right? So how to choose? How to choose? Remember when we were in lecture number 1, we are talking about the data type of thematic attributes, right? So based on the level of measurement, we have nominal, ordinal, interval, and ratio, right? Really, we have two types, qualitative and quantitative information. So if the field is going to store qualitative information, like nominal, a name, or ordinal, an order, we are going to use text. If it's the quantitative information, well, if you have decimal places, we use integer. If we have float or double, like decimal places, we use float or double. There's no big difference, okay? The difference between short integer and long integer, well, is just how many numbers you can store there. As you can see, short integer have narrower range, but long integer have wider range. This is the storage in computer science, so you don't have to worry about too many details here. Okay, so if your integers have a wide range, you're going to use long, otherwise you use short. Same thing like float and double. Okay, float will be less precise than double. Okay, here we're talking about precision. Okay, so I won't go into the details. Okay, too many details about this. If you are interested in learning what's the exact difference between float and double, check out this link. Okay. In addition to numbers, okay, we're going ArcGIS, especially in ArcMap, ArcPro. Well, you can also record date. Okay, you can also record other things. We won't go into those details, but if you're interested, you can click on this link to learn more. Now let's talk about a really important thing. It's called table join. So what is table join? Let me give you this example. Okay, so for example, we have this wood layer. Okay, for each wood we have ID, we have other attributes. Okay, so as you can see here, each column here, remember we call that a field. Each row we call that a record, right? Okay. Then you can also define your key. what is a key? Is a unique identifier, okay, that can help us identify different polygons, right? Okay. So now I have a question. Okay, so here I have land use code, but I don't know what does that mean. Okay, so I want to look it up. Okay, land use code. Oh, 300 means national park. Okay, 350 means private. Okay, the ownership is private. Well, then it's okay. I have this information stored in a separate table. But what if I want to calculate how large of the woods, how many of the woods, okay, square miles, the size of the woods is owned by the national park, right? How to combine those two tables together? Then we are going to use the table join. Okay, so how to do that? As you can see here, this field land use code is shared by both table, right? Okay, 300 means national park and 300 is related to these woods. Here's an idea. I can base on this code to populate the records, right? Each row here to this targeted attribute table, right? So for example here, oh, I see 300, the land use code means national park based on this table. I can attach this row to the end of the first row in our attribute table. Same thing like this one, but for this one, 350, oh, here, share the same land use code is private. Okay, so I'm going to attach the second row instead of the first to the end of the third row in our attribute table. Then I will have this join table. Okay, so now if I want to calculate, okay, how large of the how many square miles of the woods is owned by national park? Well, 50, 20, 70 square miles, right? So you can see here, you actually can use this table join to enrich the information in your currently recorded in your attribute table. Okay, so the key here is to find the common field. Here is one thing, keep in mind, you don't have to have the same name, okay, for the common field in different tables, but you have to have the same information. Okay, so in our next lab, you're going to practice this, how to do the table join using the data from US Census Bureau. Okay, so here's another example. Okay, you have this table 1, okay, different building types, okay, and for different buildings, you have the common field, and you can use this field to match, to join table 1 to table 2, right? Here, you can also calculate, okay, how many buildings, okay, is their apartment, how many buildings their houses, and how many occupants, okay, right, in different type of the building. Okay, so there's a lot of applications, and it's a very useful operation in GIS. Okay, so in the next lab, you're going to practice this. I want you to think about how table join works. Okay. All right. So just a side notes. If you are out there to download the spatial data from various website, how you can tell it's a vector data file? Well, you need to know the commonly used vector data file. Okay, so you will see a lot. It's something called shapefile. Shapefile is a vector data model, but keep in mind it's a non-topological vector data model. Okay, and it will be weird. Okay, if you look at your shapefile outside GIS software. Okay, outside ArcPro, ArcMap, because you will see a quite messy thing in your windows, okay, in your folder. So you can see here for one layer census tract, okay, census tract, you will have tons of files, I will say. Those files share the same file name, but with different file extensions. Okay, but the good thing is if you open this shapefile in your GIS software, for example, ArcMap or ArcPro, well, you will see actually just one layer is called census tract UTM zone 10 north. Okay, because GIS, the software is able to combine all these files together. So I highly recommend you will organize, okay, your data with GIS software. Don't do that in your normal folder. Maybe you will, accidentally delete something. You won't be able to open your shapefiles anymore. Okay, so do that in your GIS software. Okay. Well, this is our attributes and locations stored in vector data model. Then how about topological vector data model? What is topological? Relationship, right? Topological relationship or topology actually is define the relationship between points, lines, and polygon. Make long story short, is a set of rules to define the relationships between points and lines and polygons. Let me give you an example. For example, we have this so-called polygon topology. You can define, well, those two polygons, they have to share this boundary. Okay, it doesn't matter how you change projection, how to, distort the shapes, but they have to share this boundary. Okay, you can also have this so-called arc and node topology. Well, for example, those two roads, they meet together and continue to this road, to this node, right, to this destination. Okay, and maybe those two highways, okay, they overlapped with each other, but it's not the same road. Okay, you will have this one on the top, okay, this one at the bottom, right? So that's a set of rules. Well, why we want to record topology in certain cases? Well, spatial topology or spatial relationship is a key aspect of geographic information. Very important application is it allows us to do network analysis. For example, from point A to point B, what's the best route, right? Okay, depends on the traffic, right? Okay, you can also do buffer. Okay, well, buffer is not just a distance, right? You can also do 5-minute walking distance, right? At different time of the day, right? Okay, so this is one thing, okay, which makes sense. Which this is one thing we can do with topological relationship defined in our data model. Another thing is topology is also a key requirement for data management. Okay, well, data management, we're really talking about data creation, editing, and storage. So if you put your feed, if you're out there to create the data or adding the data, topology actually can help us prevent, detect, and correct errors. So for example here, okay, you define those two polygons, share the boundary here. Okay, then if you want to resize one polygon, like in this case, I want to shrink this polygon, with topological relationship defined, with topological editing, well, you won't have those gaps. But non-topological editing, you will end up with these gaps because this polygon, purple polygon, doesn't know it's adjacent to this yellow polygon. Okay, you will end up with those gaps, which is meaningless. We call that sliver polygon. Okay, and the data storage topology helps us to minimize the redundancy. So for example here, if you know the relationship between those two polygons, they share the boundary here. For those nodes, for those points, you only need to store twice. once, but non-topological model, you need to store them twice. Okay, so this sounds a little bit simple, complicated. I highly recommend you check out this video made by the University of Toronto. This professor, he will introduce you more details why we want topology. Okay. All right, then topology sounds amazing. How to define topology? Well, here we need to first define some topological primitives. Okay, so here, vertex. The first one is vertex. Vertex is equal to shape points. Okay, so for example, for this line, those vertex, really shape point, help to define the shape of this line. Okay, and each straight line here, we call that line segments. Together, we call it polygon. Okay, well, then node is a very special vertex. Okay, why special? Because it has some geographic meaning. For example, here, a node can be an intersection like this one, okay, where two arcs meet. Arc is a line, okay, it's a line segments, okay, and a node can also be an endpoint of a Downing arc. So, for example, this is a line segment. Okay, it's an arc. Well, it stopped here. Okay, it's just like a Santa Monica Pier. Okay, and then a node can also be an isolated point, like here, like I don't know, a well or a house in the middle of nowhere. Okay, so a node is a vertex, is a special vertex with geographic meanings. Okay, then arc or link or edge or line segment, okay, is a directional line, okay, with starting node and end node. It have some direction, okay, start here and here, okay. And then last but not least, a polygon, or some people call that face, is an area enclosed by a set of arcs. So you have a direction here. Okay, with that, with those primitives, we can store the topological relationship in our vector data model. Okay, so there's many solutions. There's how GIS, Esri coverage this specific data type, okay, handle the geographic, the topological relationship. Okay, very simple actually, 3 steps. Number 1, you have this point attribute table, easy. You just need to record the point, the ID, and then record the coordinates, right? Okay, simple. Step number 2, we need to define the relationship, right? We need to first define the relationship between your arc, the lines, okay, directional lines, and nodes. Okay, first you want to identify what are the special vertex, what are special nodes. Okay, it's right here. Okay, so you will have your node identified, for example here, node are those yellow points. Okay, with those node, you can start define your arc. So for example, arc number 1 start from 21, stopped at 22. Then from 21 to 22 is the direction of arc number 1. Right? Okay, arc number 2, let me find it where it is here. Okay, it starts from node 22, okay, and end at 23. Okay, so arc number 2 kind of like goes this way, right? And so on. Okay, for each arc, you're going to define the shape points. Okay, the shape points. So for example, arc number 2, start from here, from 22, and then next is the vertex, 6 and 10, and then 9, 7, and 9, 5, and 5, 5, and here, right? And so on. So with that, you can see each arc, they don't just have the shape, also have a direction, right? You cannot go from 23 to 22, but 22 to 23. With that, okay, we can define the arc polygon table. Okay, so you have an arc, you have nodes, okay, and then for each arc, for example, number 1 is from here to here, okay, And if you follow the arc direction, you will have your left side and right side. So your left side polygon is 150 right here. Your right side polygon is 151. It's right here. Okay, and so on, and so on. Okay, with that, well, I know 150 and 151 share the boundary, share the arc as 1. Okay, and then for each polygon and arcs, okay, polygon 151, you can use the arc to help define the polygon. Okay, so you can see 151 is this polygon. Okay, we have arc number 1, arc number 4, arc number 5, and arc number 7, which is a hole, is an inside, is a hole in this polygon, right? Okay, so we record the arc name, and also we use a 0 to identify, okay, any arc after, okay, this 0 is inside edge of this polygon. Okay, and then for the arc, you can define the coordinates. Okay, so this sounds a little bit complicated. I won't ask you to encode those polygons relationship like this, but you can see we can use those tables. Arc polygon table, arc nodes table, or point attribute table, right, to together define the relationship between points, lines, and polygons. Okay, all right, so here, what are the common use topological vector data model? Well, array coverage is the most commonly used one. It's a very classic one. Okay, I want you to check it out. Okay, to read more about how array coverage help us define the relationship. Okay, use 3 types of tables. Okay, and also we also have array geodatabase help us define topology. U.S. Census Bureau, the tiger actually represent topological integrated geographic encoding referencing. Okay, so it also have topological relationship defined. Okay, another thing is USGS, digital line graph. They also have the topological data defined. Okay, so check it out if you're interested. All right, so let's summarize what's the pros and cons of vector data model. Okay, pros for vector data model is geographic features are treated as individual objects. Okay, because we see the world as discrete objects. Number 2 is, well, spatial location, especially for points, right? Okay, can be very accurately recorded, encoded in your data model. Okay, and attribute data is stored in relational database, which make it very, very easy for us to bring in more additional information to enrich our data. Actually, in AppPro or ArcGIS Online, we call table join, enrich your data. Okay, so we'll practice that in our next lab. Okay, number 4 is if you want, you actually can store spatial topology. Okay, which you can see is impossible if you use the raster data. But vector data model also have some cons. It's compacted, especially when you use topological data model, right, to reduce the redundancy. The cons, the downside, is quite complicated. Okay, and to be honest, it's very complex for spatial analysis. In this class, you probably won't feel that, but if you're out there to do some, coding, programming, you need to address, okay, the ways to vector data model, how vector data models store, for example, location, for example, semantic attributes. Well, the location and semantic attributes, the way it's stored, actually is quite complex for coding. Okay, so this is, let's save that for later. Okay, so this basically is this part of the lecture. Okay, we learn how vector data model represent geographic data. I want you to know specifically how vector data model represent location and semantic attributes, and very important, how to do table join. Okay, so you don't have to worry about the topology, okay, and the cons, how to do programming with vector data model. That's for our advanced class. Okay, so this all for this part of the lecture. Okay, vector data model. In the next part, we are going to talk about how to use raster data model to represent spatial data. See you in the next video.